So I'm just going to share very quickly like my thought process as I was coming up with my lesson implementation last year, and then kind of take you through what exactly I did. So I taught last year and will be teaching this year 8th grade physical science, and last year was my second year teaching 8th grade physical science. Prior to that, I had been teaching 7th grade, and for my student teaching, I had also been teaching 7th grade. So I finished off my first year and was very eager to learn more about physical science so I could kind of, as Angela has really been pushing for, incorporate the curriculum into more of a storyline as opposed to just isolated topics, as I had been teaching it that first year. I did have the opportunity to implement a climate change curriculum my first year, and so I really wanted to focus on that, but then also supplement with additional storylines. And so, really, I was looking at redesigning my curriculum storyline wise, but not necessarily changing too much of the individual activities. And so, what I found within this workshop was that the types of activities that Angela introduced us to really were I could see their connection as really strong introductory activities into what I wanted my students to take away right at the beginning of the year. And so I really pushed to implement this at the beginning of the year last year. I knew I wanted to use this as an opportunity to focus on developing models and forcing students to visualize their thinking, as well as focus on developing their scientific and argumentative writing as well. And I knew that nanoscience would be using nanoscience as a starting unit would be a really great opportunity for me to front load information about waves for my climate change unit. And so I really, in contrast to what Jenny will talk about later, I really took this as an opportunity to use nanoscience as an opportunity to teach waves as opposed to just teach an entire unit about nanoscience on its own. So I focused on MSPS 4.2, which is essentially develop and use a model that describes that waves are reflected, refracted, and transmitted through various materials. So again, the focus was on electromagnetic radiation, developing and using models, and then structure and function. In particular, I really was drawn to the thin films activity, the polish your name tag activity that we did yesterday with the nail polish and the black card. And the reason why was because I could see it as a very easy activity to do at the beginning of the year. It held a lot of relevance to me because I could see students personalizing that as a name card, but then also including other information. And then it would be a very nice product for back to school night. But just lesson wise and story wise, I really liked this activity because there was a very clear and observable change that students, I felt, could identify. You have clear nail polish that becomes iridescent when it's on water. And so that really contributed to this idea of a storyline that we could explore throughout the unit. It was simple, colorful, and artistic. And I feel like a lot of the times, students have this idea that science is dry and about numbers and about and I wanted to bring in design and art a little bit more to my class throughout the year, because I do think that providing those visuals gives an easier access level for all students, and it helps them develop and revise their explanations visually, which is something that they don't often have the opportunity to do. And then there are very clear connections that they are able to make to other commonly known phenomena. So oil slicks and butterfly wings. Some of my students actually brought up hydro dipping, and then of course bubbles. Like they've visually seen these phenomena, and so it was relatable. And so my unit was a very short introductory, like mini unit, really. I started off with like a pre-lab where they measured out different amounts of blue, yellow, and red liquid, and then they created a rainbow assortment. And then pretty much the next day I had them do polish my name tag with the nail polish. And then we started to explore, well, what is the difference between the test tube array of colors and then what you're seeing with your name tag? What's the difference between that iridescence and the colors that you see? How is it that we're able to perceive colors? What is going on with light? Just background-wise, I had about 25 to 35 students per period, and It worked out pretty well where we had, I think, one large tray between a group of four, and each person got to make their own name card. And I think some people might have had samples that they were able to dip and test out, or they made too. So material wise, it was pretty easy to set up. And this unit definitely morphed from like a general wave unit where I had wanted to include sound to just focusing on light, which worked out a lot better. I've included like a list of challenges that I faced, both in terms of mistakes that I made, as well as in trying to get students to model, to visualize what they were seeing. Wanted to use color pencils, but I found that some of my students, and it worked out well when I tried it, but some of my students wrote very lightly, and so it kind of washed out in the end. So the whiteout pens, the white pens, the Sharpies worked really well. The color pencils did work, but they really did have to apply force as they were using it. I had them write their name on the front and then their definition of science on the back, and it was a really great display on the wall for back to school night, and for some reason I did not take a picture of it. But I think, as Angela mentioned yesterday, if you're putting the paper in the water first and then putting the nail polish on, sometimes the paper can get soaked and fall apart. And so including practice strips for each group kind of helps students figure out what the technique was. Once they did the activity, they were very quick to start posing questions. Does it have to do with like cellulose, or what is going on? Is there like oil in the nail polish? Is there some sort of compound that's causing this? But then when we were putting that down onto paper, they needed a little bit more guidance in terms of, well, how are you going to show this? And so there were specific moments throughout my unit where I had to walk them through, and we modeled that. This is definitely something that I want to do for distance learning, and I've been thinking about whether there might be an alternative with like cooking oil at home, but also I do think that I'm going to demo it so that students who would like to try it on their own can. From there, we went into exploring refraction, reflection, and how light behaves with prisms. And so again, as I'm thinking about implementing this lesson these lessons during distance learning, I'm trying to think of what materials my students have at home that they would be able to use. So it's very easy, hopefully, for them to get a clear cup where they can put a spoon or some sort of object in it and fill it up with water. For the reflection activity that we've typically done, they do have access, hopefully, to the bathroom mirror. And then for that particular activity, I only focused on smooth surfaces, but I think I want them to be able to have a rough surface as well. And then they'll hopefully have their phone flashlight or some sort of light source that they can use. And then, of course, if you use gizmos, I think that had a really great prism simulation that you could send your kids to, but also that has one for bending light that covers, again, refraction, reflection, prisms. I think it's a little harder to use than the gizmos, but I mean, it is free and easily available. I also made sure that they got together in groups to create a group model. So I gave them a list of things that they needed to include in their model, which was observables, things that they couldn't observe, which was where the light waves came into play. What the connection between those two things are. They needed to have the visuals. So they should have, at the end of the group model, shown that the nail polish was a thin film and shown how the light waves were interacting with that. And they worked really well with each other. And these are some of the finished products that you can kind of explore. We did do kind of a gallery walk where they had an opportunity to give everyone feedback, because I felt like it didn't really tie into, or it didn't bring in all of nanotechnology as I had initially hoped. I did want them to understand technologies were possible through the use of light and thin films, and just nanotechnology in general. So we did do the sunprint lithography, and then to kind of help them explain what the relevance of the sunprint lithography was to technologies, we also watched the Intel clip, The Making of a Chip, where they actually kind of simulate what goes on in making a transistor. So they actually show through simulations like the masks, exposure to the UV light, and then the building up of the transistor. So the sunprint lithography was pretty popular. I tried to go as cheap as possible. So I purchased the large sheets so that I could cut them down. But then I also purchased 9 small sets, and I got them all from, I think, Lawrence Hall of Science. I got the small set so I could get the acrylic and I didn't have to cut it myself. And then I chopped up a bunch of transparencies for the top layer, but I also used cardboard for the bottom layer so it would be easier for the students to hold. And I made them make the mask for homework so that it would save on time. I didn't remember to tell them to just use black markers, so we actually had a few duds where I think it was the blue pen didn't work. So it didn't block light effectively, whereas the red pen had limited effects. And so that might be something that would be interesting to play around with when we're back in physical school, or if you can mail these out to your students. But yeah, they made all sorts of designs. Some of them use organic materials, but they just use leaves or branches or tape and paper clips, all sorts of weird things. And some of them are super skilled artists. Um, Unit wise, I think I asked for their feedback and they really did enjoy, and this is mostly their own words, but I put in phenomena. They enjoyed being able to make sense of things that they'd seen before, but they weren't able to explain. They liked making the connections to technology and techniques that they're familiar with. They really liked the complexity, despite it looking simple. They like the opportunities to create instead of just regurgitate, and they like the opportunities to work together on the group model. I felt that it was a great anchor for skill and content. So I constantly referred back to this unit when we were talking about waves, whether it was for climate change or later on for electricity and magnetism. I think it did require sort of the students to rethink how much direct instruction they wanted versus how much they should be able to pull from their labs. It wasn't something that they were completely used to. They really liked getting the answer right away. So I constantly had to tell them, well, did you look at your data? And we had to kind of go back and forth with questions. I feel like if I were to do it again, I definitely want to include the how big is it card sort, to provide students with a more explicit explanation of like just the concept of scale. Again, the rough surface for the mirror activity, because when we started to talk about interference, I think the fact that light doesn't just, I think the rough surface helps with the fact that light doesn't always reflect at the same angle. And then I decided to just have them go back for their group model to the original thin film activity, but I think changing it up and using a soap bubble or glitter would have provided a better summative assessment model. Oh yeah, and then I've included some resources too, but I think Angela has most of these as well in her resources document. But yeah, this is just my thought process in taking one particular lesson, then trying to mesh it into the assortment of activities that I already had.
That was great. Thank you, Kirithika. I do see a question, and obviously everyone is welcome to ask Kirithika any more detailed questions. Amrit had a question on, did you put one bowl of water per kid or one bowl per lab bench?
Oh no, yeah, no, it was one container of water per group of 4, not for one for a kid.
Yeah, maybe chaotic.
Yeah, and then I think the water got kind of gunky after each period. So there were points in time when we kind of dumped it out and then refilled it too.
Questions or comments? Yeah, I think personally, I was just really impressed with how Kirithika sort of was able to fit and adapt the nanoscience stuff really into the curriculum and not make it seem like kind of randomly stuck in, right? So I thought that was really impressive, and you'll see some other examples of Jenny. Jenny just went on, a whole wild chase, I think, and you'll see later today. But maybe now we have some time, we can sort of talk about maybe your current concerns about lesson planning and worries and how logistical aspects of it. Like maybe we can take these next 15 minutes to talk about it a little bit more in depth. So please, remember that this is a safe space. We're here to support you. So if there are any questions, feel free to unmute yourself or put them in the chat and things like that. Yeah.
I guess I had an idea that's very, I don't know how realistic it is or if it could even go anywhere. We're just bouncing ideas around. But I really was interested in the idea of like building nano like materials at like a very small scale. And if there's a way for students to simulate that with some sort of activity that can represent a atom or a molecule, and maybe how they would naturally come together so they can actually like build some sort of structure. I don't know what that would be. That was an idea I had yesterday. I didn't know if anyone could think of a way to make something like that work, where students could actually like use pieces that represent something at a very small scale to build something. I didn't know if anyone had any ideas.
So Dustin, are you thinking about your astronomy class?
Not necessarily astronomy, but thinking, for example, like carbon nanotubes, and then giving them. I don't think that would be the best idea because it's pretty simple. I mean, it's just that one shape, and you just repeat that over and over again. But something where you could take something like a carbon atom and, or maybe give them a variety of tools to try to accomplish something and build something,
Okay.
But have it represent the rules or the physics at the nanoscale.
Yeah. So I have an activity for you that may be helpful. And some people are putting in the chat, yes, the spaghetti structures or towers. Actually, so one thing is there's a fun activity where you have to be like a nanoscientist, and you have to wear kitchen like oven mitts and then use regular Legos to assemble something. So it's kind of you like struggling to put something together and realizing, because it's so small, so nanoscale, you have to use like a tool to help you do that. But I'm seeing people brainstorming in the chat, and I'm wondering if you could make a spaghetti tower, right? But then use oven mitts to try to use the spaghetti tower, or make the spaghetti tower. I mean, so that could be a fun kind of remixed version of that. Yeah, oven mitts and a tweezer as a tool as well. I don't know I feel like oven mitts are an easier thing, or even mittens. I guess we're in California, but some people go to Tahoe, or it gets cold sometimes. So yeah, you can use like mittens as well. You've also included information on, you can make silver nanoparticles. That would be a little bit harder. I don't recommend it just because some of it is not the safest, and it's kind of expensive. But yeah. And then Usha had asked if anyone is sending materials to their students. I think that was also a good question as well. Yeah. Yes, no, maybe. No, I see a lot of no's. Yes. I think
I have 170 to 180 students, so logistically, that would be quite the challenge.
Yeah.
We don't know how we're teaching, how many kids at school, how many kids at home either. So we don't have direction yet.
Yeah, thanks for that. That was really cool to get all those ideas.
Yeah. Okay. Anyone else? Any other? And they don't have to be full thoughts. They can be half thoughts. I will accept all unformed or formed thoughts when it comes to that. Because I think here we can really talk to each other, give feedback. That we have a wealth of resources here. We have probably like hundreds of years of teaching under everybody, like collectively. So feel free to chime in.
Does everybody have kind of an idea of what they want to do for their lesson plan already?
Sort of.
Okay. Or like, a favorite activity. Okay, maybe nope is okay too. So I will say, just to give you guys some sort of idea, like for the next couple of days. So obviously today we'll have, by the end of today, we'll have gone through most of the content that we're going to go through. I'm going to assign you again as homework, obviously, to work on your lesson plans, but I'm going to send you the resource page that I was talking about. And actually, let me share with you what it looks like. And it's going to be an ever evolving piece of paper, or digital piece of paper. But basically what it will go through is every day, all the links, day one, here, let me make this bigger for you. It will go through, so you will be able to sort of review everything. Because I know, like I said, this whole workshop has been really a sprint. Usually it's more like a marathon. Like this round, it's been a sprint, but you'll have access all in one place, the slides, all the activities. They also have different guides, like the student guide and the teacher guide. And if you think you don't like the way it looks or you see a typo, please tell me because I can modify it. And the service area, we have some lesson planning stuff that is already there. It should have been posted, but in case you need it, it all is kind of living here as an outline. And again, some of all the stuff that we sort of went over, so I won't go into too much detail. But as part of your homework, it's going to sort of look through the teacher resources that are here. So there's, I started adding to this obviously, but for example, but then some of the PhET simulations. Later today, after lunch, we're gonna do an activity with UCSD. Yves is actually on the call. He's been observing our workshop, but one of his colleagues from UCSD, Ryan, is going to give us a demo of the scanning electron microscope, which will be really fun. But this is something that you can actually invite into your classrooms remotely. So you could send samples out and have us or have them take a look at the sample. And then obviously you can contact me for any of those remote tours. But then also there's a lot of information here. So these are the ones that I personally thought were good that you can take a look through and play around with. Like there's, I'm not the end all be all when it comes to nanoscience. Plenty of people have worked way harder and better at assembling a lot of materials. So this is a few examples of that. And then, so mostly these are kind of organized as big libraries of information or activities. And then over here are some of the readings that are really good that I really like. The one that, and I added just the ones that Kiruthika had sent. This one I really personally love, the What is Glitter article from the New York Times. It's super cool. It's like, there's like mystery involved on who is the largest purchaser of glitter. I personally love glitter. So it's really interesting how glitter is made, because glitter is actually a series of thin films. That's why it's so reflective. That's why it can be iridescent. So yeah, that's a really cool article. There's also some reading material for nanotechnology for kids. This is actually submitted by Jenny. And a lot of other little interesting articles that I found were really fun, interesting reads. And then over here again are the videos that I was talking about. And so you can get a better sense. So this one you already watched, this one you've already watched, but obviously you're welcome to review some of the other ones. There's actually a Khan Academy, series where it's sort of the scale of the universe. So it goes from really big to really small, but obviously we focus on small stuff. So I linked that one in particular below. And then a lot of other videos that you can take a look. Oh, and one of our colleagues from RTNN, which is the Research Triangle at UNC, Duke, and North Carolina, they had a Takeout Science series, which is really fun. We're going to actually contribute to it as well, but they have a whole set of weekly shows. So they're already pre-recorded and on YouTube. They're usually like 30 minutes up to an hour, but they have a whole bunch of information too. And so they do like, they do like a pollen one. So they talk about all the different types of pollen. So they have each week has a theme. So I really like that one as well. And the person, her name is Holly. She does a really good job giving you a good sense of what's going on. And this is, again, using a scanning electron microscope. Okay? And you're going to have access. I'll submit it. I'll send it out right after this. Oh, and then one thing I think obviously is really timely is this whole series on COVID-19. They did it by Vox created it, but again, the coronavirus or a coronavirus is on the nanoscale. It's a few hundred nanometers. I think 20 to maybe 20 nanometers. I can't actually remember right now. But they do, they characterize the coronavirus. So they actually use a scanning electron microscope to image and understand the structure of the coronavirus. They also explain why soap is so important for the coronavirus to prevent it, right? Part of it is because it's going back to that self-assembly thing, right? The coronavirus is this has this a lipid bilayer and soap will disrupt it because it's a surfactant and it can penetrate through. Otherwise, water will not do that alone. So I think that's a really good example. And then why masks matter. Again, this is sort of going back to nanotechnology, or things, at the micro and the nanoscale. The masks that, I talked about this, I think, on Monday, but the masks are typically charged with something so they can attract any sort of particles in the air. And then also the weave of the mask is actually really important because it acts as a filter. If the weave is too big or too small, they won't let enough air in, or they'll let the virus in and things like that. So these are a really cool set of interesting series as well, if you want to learn more A, about the coronavirus, and then B, sort of the science behind it. Okay, so that's going to be part of your homework, is to just review some of the resources and then sort of report back which resources you liked, or maybe the resources that you didn't like, or any maybe resources you want to add to this whole page, because this is kind of your page, or your holy Bible, or what. I don't know why I'm getting very religious about it. I don't mean to, but I don't know. But anyway, it's your your thing that you're going to focus on as you move forward. And you don't always have to post to Google Classroom, because I know that can be sort of annoying, but this is sort of a whole thing that you can download and save and all that. All right. So with that, do you guys have any questions, comments, concerns? Do we want to talk more about lesson planning? Because obviously I can stay on, or I'm happy to stay on.
I have a question about the resource page, because this is the first summer that I've had as a teacher, and I'm curious if there's an area on the resource page where maybe people could link to other, I guess, trainings or camps or summer activities like this that are still working through Zoom, because a lot of the ones I was interested in got canceled, a lot of outdoor activity
Yeah,
ones,
I can do that as well.
but just I'm sure there's lots, and I've tried to research just Googling stuff, but if there's any cool opportunities like this one, a little blurb on that page would be cool.
Sure, yeah, I will do that, and I will make it editable so anyone can add to it as well.
Cool. Yeah, thank you.
Mm-hmm. Okay. All right, well, if that's it, I will stay on for a few minutes after. Otherwise, yeah, I will see you at 1:30, okay? All right.